Bismillahirrahmanirrahim, my dear students. Here is your mathematics teacher Muhammad Amjad Said from Pakistan International School, Taif, Saudi Arabia. Today we will continue our lecture number 76, exercise 8.3. Identify question number 9, part 1. There were two parts given in your reduced syllabus, part 1 and 2, and I have chosen part number 1. So here is identify the series and find the sum. So first of all, this is the given series, and actually we have to confirm this series as the binomial series. We know that 1 plus x power n is equal to 1 plus nx plus n into n minus 1 over 1 into 2x square n into n minus 1 n minus 2 over 1, 2, 3 or 3 factorial plus so on. This is, suppose this is series A. We have to find the unknown values n and x, and after finding n and x we will put here in equation number A, then we will confirm this series, and after that by using x and n on left hand side we will find the sum of the series. So from this series A we can confirm our series along with the sum of the series by having left hand side n and x are unknown. We have to find these two values. Comparing above two series. Comparing above two series, first is equal to first, second is equal to second. So nx is equal to minus 1 by 2 into 1 over 4. So nx is equal to minus 1 over 8. X is equal to minus 1 over 8n. Dear students, this is the value of x in terms of n. This can be taken as equation number 1. Here this is 1. Also, second term is equal to second term by comparing. Then third term is equal to third term. We will have n into n minus 1 over 1 into 2x square is equal to 1 into 3 over 2 factorial into 4 1 over 4 square. Using value of x here, n into n minus 1 over 1 into 2, x square mean minus 1 over 8 n whole square. This one is equal to 3 over 2 factorial is 2 into 1 is 2. 2 fours are 8. Here is 1 over 16. So dear students, we will have n into n minus 1 over 2 into 1 over 64 n square. 3 over 128. 3 over 3 1 the 3 16 into 8. 3 over 128, and here is 64 into 2. It is also 128. So we can have n into n minus 1 over 128 n square. That will be 3 over 128. N into n minus 1 over 128 n square. So 128 cancelled with that, and 1 power of n is cancelled. We are left with n minus 1 is equal to 3n. Take this n to the right hand side. Here we will have 3n minus n. 2n is equal to minus 1 and n is equal to minus 1 by 2. So dear students, using this value of n in equation number 1 to find the value of x. Using n in equation 1, x is equal to minus 1 over 8 into minus 1 by 2. Minus minus plus 2 fours the 8, we will have 1 over 4. So x is equal to 1 over 4. So dear students, we have value of n as minus 1 over 2 and value of x is 1 over 4. Using these values of n and x in series A, then we can find our answer. Left hand side will be the sum and right hand side will be the confirmation of this series. Yes, we have. Here we can have using values of n and x in right hand side of equation A. Actually, I want to confirm right hand side as this series. Left hand side is the sum. You will find afterwards. 1 plus n. N is minus 1 by 2 and x is 1 over 4. Plus n is minus 1 by 2, then minus 1 by 2, minus 1 over 1 into 2, x square mean 1 over 4 square. Then plus n into n minus 1, n minus 2, divided by 1, 2, 3 into 1 over 4 cube plus so on. So dear students, this is plus minus minus 1 over 2 into 1 over 4 plus minus minus 1 over 2 into 1 over 4. Actually you can see this second term here. Next is minus 1 over 2, 2 1 the 2, minus 2 minus 1 is minus 3 over 2, over 1 into 2 is 2 factorial, then here is 1 over 4 square, minus 1 by 2, minus 3 by 2, minus 5 by 2, over 1, 2, 3 is 3 factorial and 1 over 4 cube. Now dear students, 1 minus 1 over 2 into 1 over 4 minus minus plus 1 into 3 over 2 factorial, but this 2 into 2, 4, it will come down and this is 1 over 4 square. You can check your third term. 1 into 3 over 2 factorial into 4, 1 over 4 square. Similarly, minus minus plus plus minus minus. Here is 1, 3, 5. 1, 3, 5 over 3 factorial, but this is 2 to the 4 to the 8. 2 to the 4 to the 8, it will come down. And here will be 1 over 4 cube. So dear students, you have seen right hand side of equation A, that is the same. So it is the confirmation, it is the identification of the series as binomial series. And find sum now. Now what is sum? Sum is equal to 1 plus x power n. 1 plus x. What is x? 1 over 4. This is plus 1 over 4 whole power minus 1 over 2. N is minus 1 over 2. 4 1 the 4. 4 plus 1 is 5 over 4 power minus 1 over 2. Dear students, you have negative power. If inside the bracket you take reciprocal, sign of power will change. If you take reciprocal inside, then sign of power will change. It will be 4 over 5 power 1 over 2. that will be 4 over 5 whole under root. 4 will come out as 2, that is 2 over 5 under root. Dear students, that was the sum of your series. I hope that you understood this question. And here we have yes, 2 over 5 under root. So that was your first part of your question number 9. Dear students, part number 2 you can do by yourself. It is very easy and just you will trace all the steps in fact. After that we have question number 10. Use binomial theorem to show that this is equal to 2 under root. Here in this question, your right hand side as 2 under root is given. Actually 2 under root is the sum. This is the sum. So we have question number 10. Question number 10. Then 11, 12 and 13 they are exactly similar. So I will take one from them so that you can have better idea about the other parts and you can solve by using that part. I am going to take your part question number 13. So with the help of that you can find the solution of other questions. Here is question number 10. Use binomial theorem to show that. Use binomial theorem to show that. Here is 1 plus 4. 1 plus 1 over 4 plus 1, 3, 4, 8. 1, 3, 4, 8 plus 1, 3, 5 and 4, 8, 12. 1, 3, 5, 4, 8, 12 plus so on is equal to 2 under root. Dear students, same method, same technique. We know that 1 plus x power n is equal to 1 plus nx plus n into n minus 1 over 1 into 2x square plus n into n minus 1 n minus 2 1, 2, 3 x cube plus so on. This is your series A. By comparing, we get, basically we have to find the value of x and n to find the sum as 2 under root. This is your answer in fact, it is the sum. So we need two values n and x. So by comparing these two series, we will get the value of n and x. So by comparing, we get first is equal to first, second is equal to second, and x is equal to 1 over 4. And x is equal to 1 over 4, x is equal to 1 over 4n. So this is your value of x. After that, third is equal to third. N into n minus 1 over 1 into 2 x square is equal to 1, 3 over 4 into 8. Remember that it is not 1.3 or 4.8. These are multiplication sign. This is 3 over 32. N into n minus 1 over 2. X square means 1 over 4 n square. Put this value of x here. N into n minus 1 over 2 into 1 over 16 n square is equal to 3 over 32. Remember that 16 into 2 is 32, it is cancelled with this 32. 1 n power is cancelled out, n minus 1 is equal to 3n. 3n minus n is equal to minus 1, 2n is equal to minus 1 and n is equal to minus 1 by 2. So dear students, we have n is equal to minus 1 by 2. Using this value of n here to find x. Using x in equation 1. Suppose this is equation 1. X is equal to 1 over 4 into minus 1 by 2. This will be minus 2 to the 4 minus 1 over 2. Hence, sum is equal to 1 plus x power n, 1 minus 1 over 2 whole power minus 1 over 2. 1 minus half is half. Minus half. Remember that power is negative. Take reciprocal inside, the power will become positive. So this will be 2 over 1 as 1 over 2, 2 under root. This is your right hand side. This is your right hand side. So 2 under root is your answer. I hope that you understood this question. After that, we have question number 30. Question number 30. Question number 30. This is your last question of your last exercise of chapter 8. After that, inshallah, we will have chapter number 11. Because chapter number 11 will be included in your next test tube. So that's why I want to finish it first. Question number 13. If y is equal to 2 over 5, y is equal to 2 over 5 plus 132 factorial 132 factorial into 2 over 5 square plus 135 over 3 factorial 2 over 5 cube. 135 3 factorial 2 over 5 cube plus so on. Then prove that, actually this is your answer. Prove that y square plus 2y 2y plus minus 4 is equal to 0. This is your answer, required answer. First of all, you must check the given series. In given series, you know that series always starts from 1. 1 plus nx. 1 plus nx. So 1 is missing here. Adding 1 on both sides of above series. We will have y plus 1, 1 plus 2 over 5, 1 into 3, 2 factorial, 2 over 5 square, 135, 3 factorial, 2 over 5 cube, plus so on. We know that binomial series is 1 plus x power n is equal to 1 plus nx, n into n minus 1 over 1 into 2x square, n into n minus 1, n minus 2 over 1, 2, 3 or 3 factorial x cube plus so on. This is A. And suppose this first series is 1. Comparing equation series 1 and A. Instead of A, you can take this 2 even. No problem. That is same thing. You can name it any way. Okay. Comparing series 1 and 2. Comparing series 1 and 2. Left is equal to left. 1 plus x power n is equal to y plus 1. This is number 3. Left is equal to left. And here we have to find the value of n and x. For finding value of n and x, we will compare right hand sides of these two series. Right hand side. What is that? Second is equal to second. nx is equal to 2 over 5. X is equal to 2 over 5n. Yes, this is number 4. Here is second is equal to second, third is equal to third. Here we will have n into n minus 1 over 1 into 2x square. That is equal to 1 into 3 over 2 factorial 2 over 5 square. 2 over 5 square. Third is equal to third. Using value of x here. Using x. N into n minus 1 over 2. X square is 2 over 5n whole square. 3 over 2 into 4 over 25. Dear students, you can have n into n minus 1 over 2 into 4 over 25 n square is equal to 3 over 2 4 over 25. Yes, 4 cancelled out, 25 cancelled out, 2 cancelled out. They are cancelled out in such a way, if you bring these terms, 4 on the other side it will go down, 25 will come up, 2 will come up and they will be cancelled out. And n is cancelled with 1 power of n. You can have n into n minus 1 is equal to 3n. No, this is not n into n minus 1, this is n. N already cancelled out. So we have n minus 1 over n is equal to 3. So this 3n, it will be 3n. So you can have 3n minus n minus 1, 2n is equal to minus 1 and n is equal to minus 1 by 2. n is equal to minus 1 by 2. Yes, using this value of n here for finding x, using n. So x is equal to 2 over 5 into minus 1 by 2. 2 over 5, value of n is minus 1 by 2 here. This 2 will become reciprocal. It will come up. It will be minus 4 over 5. Yes, 2 will come up, 2 to the 4 minus 4 over 5. Using these values here in equation number 3, using n and x in equation 3, we have 1, x is minus 4 over 5, whole power n is minus 1 over 2 is equal to y plus 1. This will be 5 on the 5 minus 4 is 1 over 5, whole power minus 1 over 2. That is y plus 1. Dear students, after that, we have negative power, and this can be changed into positive power by reciprocating inside. So y plus 1 is equal to 5 power 1 over 2. 1 over 5 converted into 5 over 1, negative 1 over 2 becomes plus. So you can have scaling both sides. Scaling both sides. What was the answer? Y square plus 2y minus 4 is equal to 0. Scaling both sides. Y plus 1 whole square, 5 1 over 2 whole square, 2 cancelled out, open up the formula of scale. y square plus 2y plus 1 is equal to 5. Bring 5 to the left hand side. Y square plus 2y plus 1 minus 5 is equal to 0. Y square plus 2y minus 4 is equal to 0. Dear students, that was your required answer. I hope that you understood this question. After this, we will have our chapter number 11. Dear students, chapter number 11 has 2 exercises, and what is given to us, chapter number 11 is page 339, theorem 11.1. Sine is a periodic function and its period is 2 pi. Before we start our exercise 11.1, I am going to have the theorem that sine function is a periodic function of period 2 pi. What is meant by periodic function? Periodic function is that which repeats its value after regular interval. Yes, periodic function is that which will repeat its value after regular interval. For example, if we have f of p plus theta is equal to f of theta, f of p plus theta is equal to f of theta, then it is the definition of periodic function, and p will be period of f, period of function f. If f of p plus theta is equal to f of theta, then p will be the period of function f. So page 339, theorem number 11.1. What is the theorem? Sine function. Sine is a periodic function of period 2 pi. Sine is a periodic function. Sine is a periodic function of period 2 pi. Proof. Let p be the period of sine function. Let p be the period of sine function, then by definition sine p plus theta is equal to sine theta for all theta belongs to R. Yes, sine p plus theta is equal to sine theta for all theta belongs to R. Putting theta is equal to 0. Actually, I want to find the possible values of period, so that the value of p is to be found out in this way. So we will apply c sine p plus 0 is equal to sine 0. So sine p is equal to sine 0 is 0. So p is equal to sine inverse 0. Dear students, the possible values of p where the sine function is 0, the possible values of p where the sine function is 0 are 0, plus minus pi, plus minus 2 pi, plus minus 3 pi, up to so on. So you have seen, if you put p is equal to 0 here, then sine theta is equal to sine theta. Yes, the answer will be same, but this is the lowest value and it cannot be considered as the period of the function because it is basic and original value where we start our angle. So we will apply the second possibility, pi. Putting p is equal to pi in equation 1. Suppose this is equation number 1. Putting p is equal to pi here, in equation number 1 we have sine pi plus theta, and remember that in case of pi, 2 pi, 0, 360, 720, etc., pi, 2 pi, 3 pi, the function will not be changed. There will be no change. Here, 0, pi, 2 pi, no change. It means that sine remains sine and cos remains cos. But in case of pi by 2, 3 pi by 2, that is 90, 270, etc., there will be a change. Change means sine to cos and cos to sine. Tangent to cotangent and cotangent to tangent. This means that that one is changed. You have seen this in your 10th class, chapter number 7 even. Concept of change and no change. So here is sine theta. Pi, there is no change. We will have sine theta. But what about pi plus theta? What is the quadrant pi plus theta? You know, this is first quadrant, second quadrant, third quadrant and fourth quadrant. This is pi, 2 pi, 0. Here is pi by 2, 3 pi by 2. So, pi plus theta, which quadrant? This angle, in which quadrant? This is pi, remember, pi minus, you will go to second quadrant, and pi plus, you will move to third quadrant. 2 pi minus, you move to fourth quadrant, and 2 pi plus, you move to first quadrant. And you know that ASTC, add sugar to coffee, add sugar to coffee, and you can memorize in this way, but A means all positive, sine positive, tangent positive and cos positive. In first quadrant all positive, second quadrant only sine and its inverse positive, tangent, cotangent positive, and third quadrant sine cos both negative, fourth quadrant cos positive and secant positive and all others are negative. So you can check pi plus theta is third quadrant, in third quadrant sine is negative. So you will put sine here with negative sign here, so you do not have sine p plus theta equal to sine theta. So you can check, therefore pi is not a period of sine function. Then putting p is equal to 2 pi, then you will have sine 2 pi plus theta 2 pi, no change, sine remain as it is. Now 2 pi plus theta is first quadrant. I told you 2 pi minus fourth quadrant. 2 pi plus first quadrant. In first quadrant, all positive. All positive means this is positive sign. So according to definition, 2 pi is the period of sine function. Dear students, this is your theorem 11.1. After that, tangent is the periodic function and its period is pi. Exactly according to that, you can check from the book and you can easily understand this theorem. I hope that you can prepare from the book, and pi will be the function of tangent because pi plus will go to the third quadrant, and in third quadrant tangent is positive. Here if it is tangent, pi plus theta is equal to tangent theta. So pi will be the period of tangent function. I hope that you understood this lesson. Okay, Allah Hafiz and Assalamu alaikum wa rahmatullahi wa barakatuh.